Stay tuned for this video because I have something very interesting and important for you all here. I am Mr. Ish. Thank you for joining me. Potential energy and kinematics, which is the study of motion, can be reconciled or related with each other by means of kinetic energy, which is the energy of motion. All too often students learn a bunch of different concepts in physics, but they sometimes have a hard time seeing how those concepts are interrelated. Everything is not discrete, everything is very much related, and I'm going to show you that here in this video. We have a ball over here, tipping right here and resting at the edge of a height. The mass is 10 kilograms, the height is 10 meters. You know gravitational constant in terms of 9.8 meters per second squared, you know that. If I told you to calculate the potential energy of this object, it's easy. It's mass times gravity times height. Multiply all of those, we'll say 980, you can say meters square kilograms over second square, or you can just say joules, 980 joules. If this object is resting over here, it has 980 joules of potential energy. It can transform into kinetic energy if someone were to tip this ball off and make it fall. In that case, the kinetic energy would be exactly equal to potential energy 980. If I told you to find me the velocity of impact, and you know you can do that, you don't have to even think about kinematics, think about kinetic energy, which is equal to half mv squared. Solve for this velocity, it'll give you the velocity at impact. And let's do it. 980 times 2 divided by your mass, which is 10, and you'll square root it and see what you get. 980 times 2 divided by the mass 10, we'll square root it, we're getting 14 meters per second. The velocity at time of impact would be 14 meters per second. Now think about only kinematics. You have s is equal to half at squared. You also have final velocity is equal to initial velocity plus acceleration times time. You have everything you need right here to solve this, and mass has no relevance here. A height of 10, half, 9.8, and t squared, and solve for t. T is gonna be 10 times 2 divided by 9.8 square root. Solve for t and see what you get. 10 times 2 divided by 9.8 square root, 1.42857. The time to impact for this ball 10 meters above to the ground, 10 meters below, is 1.42857 seconds. Take this value and put it right over here. Your final velocity is equal to what we will solve. Initial velocity, the ball is at rest, 0 plus 1.42857 times acceleration due to gravity, 9.8, multiplied by 9.8, and you'll have a value which should be exactly 14. I have that value saved, times 9.8. You get 14 meters per second. And you're seeing here very clearly a potential energy is related to kinematics, study of motion by means of kinetic energy. This equation we brought over here. Two concepts which a student may have thought, potential energy and kinetic energy, with regards to kinematics to be unrelated, are very inherently related, and you're seeing that here by means of this example. You're seeing very easily how mass didn't play too much of a role when you're looking at kinematics, but mass played very much of a role when you're looking at potential energy and kinetic energy, and you're still solving for velocity at time of impact, and the end results are exactly the same. In the remainder of this video, I will show you why this is the case. Start like this: potential energy is equal to kinetic energy because it is. When an object is in motion, this relationship comes into play. mgh, mass times gravity times height, is equal to half mv squared. The masses will cancel out. Solve for velocity. 2 times gravity times height, I'm taking the 2 over there, is equal to v squared. V is equal to square root of 2 times gravity times height. This is fine. Now come over here. Vf is equal to v0 plus at. Final velocity is equal to initial velocity plus acceleration times time. This right here represents your final velocity, which you have 2 times gravity times height. Inner root is equal to 0. Initial velocity is 0. Acceleration times time. Solve here for height. 2gh is equal to, take the square root on the other side, you're getting a squared t squared, because this goes on the other side and you get a square of everything. Take everything on the other side and solve for h. H is equal to a squared t squared over 2g. G is synonymous with acceleration, and you're seeing this gravity will cancel out with one of the powers of your acceleration. You'll have half at squared. Height is synonymous with position. S is equal to half at squared. And you're seeing a reconciliation between these relationships. kinematics and potential energy by means of kinetic energy, and I've shown that to you, and that's what I wanted to show you here in this video. Everything you learn in physics is somehow interrelated to everything else, so don't think anything is always just a discrete concept, especially when you're looking at motion, examination, and energy. Thank you for watching. Have a good day.